time.
Hi, so I'm Noel Warren. I'm a carpenter and CNC operator. I'm not a professional engineer, professional programmer. Nonetheless, I think I'm going to show you something pretty awesome today. So I assume almost everyone here in the room came to Ruby through web development, a few maybe mobile development. But how many of you came to Ruby through 3D modeling? Not too many, I don't think. So this is my case. I use a 3D modeling program called SketchUp, which happens to have a Ruby API. In fact, if you Google Ruby API, the first thing you come across is SketchUp. It's pretty well documented. It has these nice object diagrams and whatnot, and there's a pretty cool community behind it. You can find both the user base and the API extension developers at sketchcation.com. Right, so what am I going to talk about today? I'm going to give you a quick hello world so you sort of get to grips about what this is all going to look and feel like. I'm going to tell you why you should care that SketchUp even exists, warn you about some pitfalls and dangers, and then talk about 3D outside of SketchUp for a moment, if I get time. Right, so here's the hello world. Be ready, Windows is about to appear. Okay. So what I'm going to do is quickly draw a rectangle over here in our 3D model and open up, oh, well, that's lucky, it's just off screen, the Ruby console. So this is basically interactive Ruby, and we have some objects that are exposed to us that come directly from the 3D model. So I'm just going to grab a handle on them. I'm going to get the entities object, which is accessed through SketchUp. Active. Have you ever tried typing when nervous? Active. Oops. Model entities. Right, so we have our entities object, and I'm going to quickly count them. Any guesses as to how many entities are in the model right now? Number 1, 2, several million? The answer is 6, so we'll quickly have a look at them. So we have a SketchUp component instance, which is this guy over here. That's, I think his name is Derek. And a component instance is just basically a group of lots of other entities, and you can nest one inside the other. And we have 4 edges and 1 face, which is what we've just drawn. So I'm going to get a handle on the face by doing, let's see. That should work. Okay, now I have the face. I'm going to do push, pull, -20 or so. And that's the hello world. So, why you should care? Money is a good reason, I think. You can develop extensions upon SketchUp and sell them. It's really interesting. This year, SketchUp has launched the extension warehouse, which is basically an app store, and, well, that helps you to market your app better. It also has an inbuilt web browser. They call them web dialogues, so you can really leverage all your knowledge about web development and whatnot. But more interestingly, I think it's really great for getting to grips with what an object actually is and how you can manipulate it, because we're essentially, we live in a 3D world. That's how we understand the world. So this really helps you to sort of get to grips with object programming. And I think this is a brilliant 10.next. If you've never programmed before, it's just not impressive. I've seen this in loads of tutorials. Like, wow, Ruby's so cool. It's only once you sort of get to program other languages you really appreciate how cool it really is. So, pitfalls and dangers. 1.8.6, that's tied into SketchUp. No gems, you have to write your own Ruby extensions. Threads are kind of broken, they behave weirdly. Development is kind of do-it-yourself. Check out Tunnel, it's a dirty little hack. It allows you to execute Ruby code that's in your IDE straight into SketchUp's Ruby. There's no sandbox. This means you'll be playing in a common sandbox with all the other plugins that are available for SketchUp. They can...
So, 3, 2, 1. No, stop, start, start. Oh, yeah. So, this is my presentation. I'm Miguel Paramon. I work at Sing in Hamburg. And yeah. And so I did this one first in Rails Camp like 2 months ago, and that was 20 minutes, and that was called Fast Tough. And right now I have to like do it fast, so it's on speed. Okay, so let's go. It's 20 slides, 20 seconds. Why? Okay, I've been like with computers since I was 8, and I found out that I spent a lot of time like typing and doing and moving things around, and was like making me waste my time. So I wanted to make things faster, and I just started really doing that like 5 years ago. And I found some nice stuff, and I'm going to show it to you, okay? Ruby related, not so Ruby related, but we'll get there. First of all, Ruby 2.0, okay? We're using Ruby 193 at Xing. I don't know if I can say that, but there it goes. And I'm using Ruby 2.0 for development, and it's like 20% faster for booting up. There's some stuff with your gems and the way the path is traversed and stuff. And when Rails loads, that's fast, so use it. Also, garbage collection tuning. Okay, I don't know how this works really. There's this guy called Boosty, and he'll tell me about it. But I put that on my ZSH, and that makes it like 33% faster, I think, or something. There's a link there. I will give, well, the whole slides are on my blog, so you can go and you can check the test, and then you can like comment on it and tell me if I'm wrong. Another one, Seus. I guess you know Spork. I guess you can also tell that I don't know Photoshop. And so Spork is about running your test in a distributed way, and that makes it faster. And then Seus runs your entire Rails and whatever other Ruby thingy you may have running around. And it makes it so that you don't have to start up and load the gems, and it makes it much, much faster. It's very nice. One interesting thing is like 58.6% Go. So if you want some Go, go for it. Another one. Oh, 2 minutes. So Sandy, yeah. Great book, great presentation, go check it out. The main thing I got from this is that we can test, and if we test well, we don't test that much, and we still have like correct coverage, and that makes our test faster and our life faster. There's a link there for the slides. Text editor, okay? Yeah, I don't want to start a flame war. I use Vim. Vim! Yeah, okay. For the Emacs guys, for the Sublime guys, yeah, learn whatever you're using and learn to use it well. And some people say like, no, I spend more time thinking than typing. Yeah, okay, but you spend like 2 hours typing every day. So if you can make that one, imagine it's 1 free hour. Go and have a drink. Your console is the same thing. This is a GIF. It's really cool, but it doesn't work on a PDF. Anyway, just get acquainted to it. I use iTerm with ZSH. And yeah, there's a bunch of keyboard shortcuts. There's readline. There's all these things. Really cool. Go for it. Keyboard shortcuts. There's Steve Losh, he's a guy from the Python community, I think, and he made that amazing blog post about how to maximize your keyboard speed by shortcuts and changing stuff around, like putting escape into the caps lock key. Really nice. Go and read it, and then come back and we can talk about it. If you still have nice problems, yeah, Shortcut. It's for Mac only, but it makes it through the accessibility resources of the Mac thing. It lets you control the computer with the keyboard. Really cool. Oh. So, Grid. This is for moving screens around. Deprecated apps, abandonware. If you want it, tell me, I can give you the app. Yeah, and then I'm now straying away from the whole Ruby thing. Okay, yeah. And the main thing is that I found that the more I customized what I was doing, the slower it made me, because I need time customizing it, time learning my customizations, and then I change computer and it's all gone. So now I'm going the step the other way around. I'm removing my customizations, I'm learning the defaults that come into everything, like Unix, Linux, Mac OS, and I feel like, yeah, this is like standing on shoulders of giants. You know, those people are really intelligent people, or at least people that have been working with it for a long time. And I try to trust them and to use what they feel that's the best option for the start, and it's working for me. You can try it out. Yeah, ads also. Ads makes computers slower. If you want to use some ad block stuff or some host files, I have a link there, something to explain. I am not blocking ads anymore because I feel like we need it as like the internet community. Some stuff are, yeah, you know, supported by ads mainly. But if you want to do it and you don't want to spend time setting things around, then do it. Don't open so much stuff at the same time. That's what I don't really have open, and it works for me. And yeah, the last thing I want to say is just uninstall, but not things, just things from your mind. If you keep your mind clean, if I keep my mind clean, I can just go faster. I can feel better. I have a bandwidth, and then I can use it in the right stuff. Exercise. Someone said something about 20 minutes a day. That's too much. Nobody has time for that. So 7-minute workout, 7 minutes a day, 40 minutes, 49 minutes a week, and that's more than enough. That's 5 minutes. Don't stop learning. And if you want to talk about martial arts and stuff, come and talk to me. Thank you.
There you go. Cool. Cool. So I'm Thomas Haggart. I work for Free Agent, which is a small web company up in Scotland. We have a web app that does accounting, according to somebody, Ollie over there. And we use delayed job, and we have done for quite some time. That's probably why we still use delayed job. We've got like 46 job classes last time I counted. And it's been fine up until a recent feature that we launched, which is basically for all of our customers. We wanted to send them on Monday morning at 9 o'clock a nice email saying, hey, you've got these invoices outstanding, you've got these expenses, bills need doing. And we realized, actually, you know what, it's not going to be much fun for delayed job to suddenly dump like 35,000 jobs onto a queue and expect it to do it as fast as possible. And so, you know, we had a look and we had a little play around to see if it would actually cope on its own, and no, it didn't. The problem, oh good, I don't think, can you see that? I hope so. Actually, before I go on, I was going to ask, does anybody still use delayed job? Like, quick show of hands? Awesome. Anybody kind of struggling with it, or is it kind of a good, okay. Well, we got to the point, we tried it out, and we ran it in a few environments and found we were beginning to struggle with it, and trying to figure out why that was. So basically what was happening, the jobs were processing slower than they were being added to the queue, the more jobs you added to the queue, which is a great thing to do, regardless of the number of workers you had. So if we have a quick look at this, this is like the main job worker, and it's a nice lovely loop, and it basically calls work off, which takes a job, processes it, does some stuff, sleeps for a bit, and goes back to processing a job. The problem in this, that the line that I've highlighted, work off, has a key problem, and that's what's the job to actually process. And there's a bunch of different things that go to deciding what the next job for a particular worker is to process. And it's the job that has the highest priority of the set. Is the job ready to run? Has it got a future dated timestamp, stuff like that? Is it locked by another worker? We want to ignore if that's the case. And are we in a race condition with another worker that's doing the same thing? We have to be very careful about how we lock access to it. So the default active record, so we use the active record backend for it. And the default way that this does it with SQL. SQL has the answer. And that's the answer. And it turns out that the more, well, it's pretty epic actually, even just to look at it and figure out what it's doing. But it turns out that the more items you put in the queue, the longer this takes. And so, I mean, we did a couple of sort of synthetic benchmarks, and we found that on a reasonable machine, it started taking 300 milliseconds in MySQL. And this is just MySQL, just to run that query when you started having sort of tens of thousands of items in the queue, which is not ideal. So what's the reason for this? We had a look. So, the reason is you've got a head of a queue. This is how a queue works. You've got the head, that's the next job to do, and you've got all of these workers. And Free Agent has grown from a very small app to a pretty big app. So we've added more and more workers, and they're all going for the head of the queue. That's what they want to know, right? So we thought about this. So what I did is I extracted out the actual SQL, as you saw before, and dropped it into like a little benchmarking system and thought, well, how is this affected by the number of workers, and what kind of efficiency, what kind of scaling we're getting from the number of workers? And drew some pretty graphs that are very non-scientific, just illustrative, really, of the problem that we're seeing. And we found this, just to really go through it. Each line is basically a number of parallel consumers running the same query over and over again with a very simple workload. And what you find is, so the one with one consumer, the red line at the top, it goes. The interesting thing about it is, as the queue empties, so what's happening here? We've got the rate that jobs are processed up on the y-axis, and we've got runtime on the x-axis. So as the job gets emptier and emptier, this is with, like, I think 10,000 jobs on the queue. As it gets emptier and emptier, the query goes faster and faster, so the run rate of this query goes faster and faster, which is not great. What you actually want is a horizontal lines here and predictable scaling. This is not predictable. The other problem that you've got, obviously, I don't know if you noticed, but the more workers you add, so as these other lines, these are the runtimes per worker, the more workers you add doesn't actually reduce the amount of time it takes to clear the queue. All of the workers get to the same point at which the queue is empty. This isn't great. So we're getting to the point where, and there is a caveat that this is simple work, so there's obviously where you've got very complicated work, this doesn't quite apply, but this isn't great. And it turns out there's a kind of universal fact that databases, I've just said that. Databases don't make good queues because of the various locking and transactional things that go on inside. They're not great. But what about a queue server? So we had a look, and there was then a bit of a discussion inside about how we actually address this. Do we jump ship and start building jobs in something like Rescue or Sidekick? And all these names came out, so we could start all this. But being the ops person, the person responsible, if it goes wrong, I thought, no, I want one way of doing jobs, please, and I want it to work well. So I thought, well, can we adjust? Can we tweak how delayed job works, kind of fix the nub of the problem to make it work for us. And it turns out we can. So what I did is I took that little test script that we've got and I tweaked it so that it still looked up from the database. But rather than doing that epic query, it used AMQP. I'm not going to go into AMQP. Oh. Too long.
Hey, my name is Daniel Scherbeck. I work at Zendesk with a few other guys who are also here today. I want to talk about a part of Rails that I think has received too little attention the last few years. That's Action View. Basically, we haven't really changed the way we use Action View since basically Rails first started lots of years ago. And I think that's a shame because it's often one of the problematic areas in the apps that we've been working on, in my experience. So I want to propose a solution that we've come up with at Zendesk and that we've extracted into a gem, and we're using this in production. But first, it's called Curly. You can go on GitHub and watch it, but I'll try to introduce it here. First, I just want to say that this is the basic structure of ERP. You have the controller, it sends some variables to the template, and it gets the output back. This is the same way that Hammer works, basically. So there's no real difference in design there. So what we propose is that we have like two parts of a view. We have the template and we have a presenter. Those match up with the structure and the logic. So this is a pretty typical EAP template. You have some Ruby in there, you have some HTML in there. If this had been Haml, it would be the other way around, but it would still be basically the same, right? You have this mash of Ruby and HTML, and if a front-end guy was to go in there and fix stuff, it would be kind of confused. This is the same in Curly. It looks a lot like Mustache or Handlebars if you use that, and that was a major inspiration. But really all the logic is gone. It's been moved into the presenter, and I'm sorry that I used the name presenter, but it sort of fits. This is basically the way that we break structure away from logic, and it has a number of benefits. The first benefit is that the templates become much more readable. A front-end person can go in, change it, add CSS classes, whatever they like to do, and just keep these small variables around. It's very, very easy for front-end people to do. Secondly, we can use all the knowledge and experience we have in editing normal Ruby code. You can use private methods. You can use everything. This is just normal Ruby. It's being executed in a way such that all the normal stuff you would do in ERB is still being executed. You can call render, you can call content tag, link to, whatever. So one of the benefits this yields is improved testing. So I don't know about you guys, but one of the areas that I find hardest to test in Rails apps are views. Sometimes it's just because, well, it doesn't make that much sense to test the views, but oftentimes it does, but it's just too difficult. So this is the way you test a view in ERB. You render the view with all the variables, and if there's some logic in there that you want to test, you'll have to parse through the view afterwards and figure out what the hell happened, and if that matched your whatever you expect it to be. But it's kind of tedious. You have to kind of parse the string you get back. It's not really optimal. You can do the same in Curly. Intentionally, we didn't change that, so all the existing view tests will match an EFB template or a Curly template. No problem. But you can also test the presenter directly. So every time you have a template, you have a matching presenter in app presenter. So post show would be post : show presenter as a class name. You can just instantiate that and test the method on it directly. So I think that's a major benefit. Because it's just methods, you know, you call them, they return values, it's great. So what you want to do is you want to test the logic, not the structure, and Curly enables you to do that. I believe there are other libraries for doing such stuff. Steve Flapnick has Draper, which is a decorator library. Also works really well, didn't quite fit our needs, and isn't quite as well integrated into Rails as Curly is. But we are using Curly for a bunch more stuff. Fragment caching is made much simpler by the fact that you can define caching logic in a presenter as a method. Yeah, you can use private methods, delegation, everything to clean up.
So I'm Cesar, and I have to tell you that 3 years ago I was doing a lot better than I'm doing today. And let me illustrate, like this much better. Right? So this is, I had quit my job 3 months right before this picture. This is actually exactly 3 years ago. I looked for this picture up. And I had been, like, until I got there, this is Mexico, I have been traveling around the world for 3 months. And for the next 9 months, that's what I was doing. So 14 months around the world. And my number one worry with my girlfriend. Now, my number one worry was not if my girlfriend would leave me, but when I come back from this trip, will I remember how to code? Well, I want to code, actually, but will I remember how to code? And I found out that actually I did learn a few things traveling, and that's what I'm going to share to you. 2 stories that happened to me while I was traveling and that did change the way I code. So, story number 1. Oh, this is root. There we go. Story number 1. The fun starts where your comfort zone ends. So the story goes, we're traveling from the United States down into Central America and then South America. We're with our host in the United States, and they're like, where are you going next? We're going to Mexico. You're going to Mexico? You're going to die. It's so dangerous there. And then in Mexico, they told us, where are you going next? And we said, we're going to Guatemala. Are you crazy? Guatemala? That's so dangerous. And this really kept on going until we got to Bolivia. And really, and let me tell you what happened when we went to Bolivia. We had fun. Guess why? Because what people have in their heads, or actually what we had in our heads as fear that pushed us or kept us in our comfort zone, when you get there, actually is completely different. So the fear in our head, what we expect of a situation, is a lot bigger than what it really is. What did I learn from this? Well, in our coding and where we're doing our day-to-day jobs, we have to get out of our comfort zone. So learn a new language, try a new library. Now, as coders, we tend to be conservative and we like to stay in control. We do like to explore every now and then, like today, all of us here. But we need to push out of our comfort zone because that's where we actually start to learn new things. Now, story number 2. There's always something you can learn from strangers. So we booked this trip. This was also in Mexico, and we booked this trip, and we were going to the mountains, and we hired a mountain guide, and we made our way to the village, and we went to the ranger's office, and there was this lady sitting there, and we're like, hi, we're looking for our mountain guide, and really you have to picture us. We had like a Gore-Tex boots on, like multi-layering, wickering, woolen thing on, like the works, everything on. It was 5 days in the mountain. And then, so let me show you who our guide was. This lady was our guide. And I was so worried. I actually read on the internet a lot about layering. And this lady, she had like 3 blankets on. You can see she has a blanket around her neck and 2 more, and actually a plastic thing also. And she had this setup that really worked for her. And she had like this plastic shoes. And she was also a shaman as well. So she taught us about the herbs and, well, all these things. And I learned, well, here I go, like thinking that I'm going to be so cool with my Gore-Tex and stuff. And she just did the same thing with 3 blankets. Now, what did I learn? I learned that we can always learn from others. We can always learn from others. We've had a few talks that said that here today. We had people that said, well, we can pair program with a newbie, that you're going to learn from that. You can read someone else's code. You can go to a hackathon. You can go to a coding dojo. And you're going to learn from all of those experiences if you have the mindset to learn from them. So, wrapping up, 40 seconds left. If programming or a programming language can change the way we think, and that is going to change the way we code. Having experiences outside of our coding life and pushing our horizons and our limits is also going to change the way we think and the way we code. Therefore, try to get out of your comfort zone, try new things, meet new people, and your code will get better. Thank you.
Hi, let's start with some fizz buzz. Everybody see this? Sort of, yes. Let's see. Wow, that's not nice. All right, FizzBuzz. We have a pretty simple code here. It's like we have a model called FizzBuzz. We have a call method. Return fizz if n is divisible by 3. Let's open up the specs. Right. Specs are pretty simple. Returns fizz with numbers divisible by 3. We code with 3, 9, and 27, and we check the results. Simple enough. Let's finish this. Let's add another spec. First, I'm going to copy this whole block over here, change this to buzz, change this to 5, and let's see, 5, maybe 25, and then let's say 125. Let's say buzz. Let's run the specs. Specs fail, as expected. Let's split this code over here, this if clause, and put a else clause, else if n. Go with the buzz, right? So far, so good. Let's go with the fizz buzz. Copy this block, put a fizz buzz divisible by 15. 15, 225, and let's go with 226 and say that this should not equal fizz buzz. Test fail? Yep, everything is all right. So let's copy this line here, put a 15, oops, 15 I said. Put an else, and put a fizz buzz. Test pass? Yep, everything is fine. Well, let's see, what can we do here? Let's focus on the specs a bit. I want to change this. I want to change this to, let's say, test. I just want to extract this here. Test with an N, put this here with an N. And this is a pretty bad name, actually. I don't like it. Maybe example? Maybe example run. Something like that. I don't know. Well, it's sort of okay. I guess good enough. Now let's see. I can sort of refactor this a bit, maybe. Change this like this. Go back here, put an initializer, I can maybe just make this a class. And I'm going to stop because I'm running out of time and it's time to talk a bit. Hi, my name is Andrew and I have no idea what's happening. How do I click this? What? Alrighty. Oh, okay. Right, so hi, I'm Andrew, and I'm here to tell you to own your editor. Now, this is my editor, like what I just showed you. It's full of these little tips and tricks, like these little scripts and snippets that I've built over the years to help me with my personal problems. Now, bear in mind, customization doesn't mean changing your color scheme. It's not just about that. It's about abstraction. It's about finding the things that stop you, the things that make you work with text and not code. So if you want to work with code, let's say you have this code here. You have this text. The moment you start thinking, I want to take this text here, remove it, and then like sort of put it here maybe, and clean it up. That's not good. It's too much thinking. You need to think about code. You want to think about, I want to move this argument to the right or to the left. I don't want to put this text here and put an end. I want to think about splitting this line into a multi-line statement, splitting this code into a multi-line code, or when I change my mind, going back to it, changing it back. And this is what I mean by writing code and not text, working with semantics and not the raw text. Now you can do this with any editor. It's like it's not a problem. Like regardless of what editor you use, there is a scripting API for it. Like if it's a program editor, you'll probably be able to customize it. but use them. The important thing is to actively look for the things that trip you up, the small snippets that cause you trouble, and just remove them. Like don't start by writing like a Ruby parser or an SQL engine or whatever. Just start with a simple mapping, with a macro, with something small that just makes it a little bit faster. Now, and this is important. You're not gonna get fast because of this. You're gonna become less slow. Think about this. And yeah, own your own editor. Thank you.
Hey guys, how you doing? So I really want to give this talk as a sort of a normal length talk, so I'm going to totally butcher the subject, so just bear with me, try and catch some of it, and then just look up the code at the end. So this is extreme isolation. It's a method of programming apps that I've been doing for the last 2 or 3 months. It basically steals everybody's good ideas from all around the internet, gives it a name, and basically makes it my own. So what can I say, you know? There's not much that's new here, but it's kind of all put it together in a particular way. I'm building apps with it. Some of them are on the internet, so go and check them out and take what you think is good. So the problem is that often our apps end up looking like this. Many people have talked about this over the last couple of days. We have lots of objects that conflate both states, mutable state, and behavior, and also the collaborators that go with those. So that is what our apps end up looking like. A couple of ways of solving this, and a couple of ways that we can make our apps more structured. One is the actor model of concurrency, which I picked up from Gary Bernhardt, which is the concept of separating arrangement of objects and the work that they do. So we might have objects in our system that look a little bit like this. The actor model of concurrency at a very basic level does something like this. It separates the fact that we're calling the objects from the actual work that they're doing. So the objects are just receiving and returning plain old Ruby objects. That's what PORO stands for. And the idea is that the objects handle the work, but they don't know about the other collaborators. They're just dealing in poros, in values, in immutable values normally. And they can be called in any order as long as you give them the right poros. So that's one concept, which is kind of loosely known as the actor model of concurrency, which is totally stolen, like many other things in Ruby, from another language. So the other idea is hexagonal rails that people have been talking about. This is the idea of using a ports and adapters model to design our apps architecture. So traditionally, we used to design Rails apps a little bit like this, where we have a web view, and then we have a big controller, and then we have our domain and persistence all conflated in an active record object often, and then maybe it talks to an external service like a mailer or something. After we were told we shouldn't do that, what we ended up doing is shrinking down the controller and sticking everything into this big conflated domain and persistence layer. What I'm suggesting, and what many other people on the internet are suggesting at the moment, is that we look at going back to plain Ruby. The idea is that you take web requests in, you deal with them in a plain Ruby domain, and then your persistence and your mailer are just two other things that you talk to. But your whole app is actually written in plain Ruby that's separate from these other kind of integration points. Okay, so taking both of those ideas and putting them together, I've basically thought about this thing called extreme isolation. So instead of having an active record model where you have your domain and persistence, we have a person repository. Now that is just a plain Ruby class that may talk to a MongoHQ layer or a Mongo layer. It might talk to Active Record. It might talk to any database you like. And it returns a plain Ruby object which represents the person in your system. This has no persistence in it at all, has no persistence logic. Okay? And I like to treat those objects as frozen. They're immutable. Okay? So the idea is that you can't actually change this thing. You can only operate on it and transform it into something else. So the idea is that instead of having this big kind of tree of different objects, you have a request that comes in, it goes into a request handler, which grabs the immutable person from an object, and then maybe transforms it to maybe edit it. Then you have a person validator which updates it. That returns two other objects which tell you whether or not it was invalid or whether or not it should be updated. Those two objects are passed to a repository and a handler. So the web handler will say, is it an update person? Okay, I'll show a success message. If it's an invalid person, I'll show an error. The person repository gets the same messages. One, it says, I'll save it. The other one, it'll ignore. Okay, so this is some of the code that might look like that. I'm not going to go through that. There's code similar to that on the net on my blog. The benefits of doing this is each object is independent. You're dealing with value objects on the edges, so you can test them really easily in isolation. That's how the tests for the web handler look. Independent tests for the person repository, that's great. You have immutable value objects. Freeze is your friend. It means that you can just drop in new things. You get all the benefits of the fact that you can make this concurrent. You can give basically concurrency to it for free. There's an example, a client I've got, a charity have very graciously allowed me to open source some of this work. That's the address, it'll be on the slides later. I've got a blog series about this on my blog, which is there. Thanks very much.
All right, countdown from 1, go. Thanks for having me. Actually, I do have 2 messages for you today. But first of all, I would like to thank Jeremy Walker, who is essentially responsible for me being here, because I did all this, and so here I stand. Thank you, Jeremy, wherever you are. The thing I would like to stress about me for the moment is I like training with my dog, not training my dog, but training with my dog, and working with Ruby. And the 2 reasons for that is joy and learning, and I think that's first message already. We have so much joy, retrieving stuff from hip-deep snowfields. It's so much fun. But actually these 2 values, and I think joy and learning is a value in and of itself, I think these are the zeros and minus first values. What I like to talk about is 2 more directly economic values. The second of those, according to Uncle Bob, is the software's current behavior. But what he thinks is much more important is the ability of the software to deal with future requests. Some people have that the other way around. One of them is Alistair Cockburn, and that's an excellent book. And look, there's even an image of a cat. So it's 2 things, behavior, current behavior. Well, I think we're reasonably good at that. We can even get better, but with all the things like Cucumber and RSpec and Minitares and what have you, I think we are pretty good at creating software that fits clients' and customers' current needs. I worry a bit more about the primary value. Who takes care of that? Honestly, I don't know. Should we let code writers do that? Probably not. But who else? Testers? Maybe people like me. I am a tester. But I don't actually know. And I would like you to think about that when you get back home from this conference. Think about what can we do to improve our system's ability to deal with future requests and future use cases of that software. Or even better, talk to me at the party tonight. I would appreciate that. Anyway, Twitter handle, email address. The slides are already up, at least the second to last version, I admit. So back to the joy of learning. I think training and rest is not the interface. It's actually having a rest, relax. That's what gives you results. That's certainly important for dogs, but I think it's also important for humans. So do that as well. Train, and then relax, and then you get results. And if you then also think about the ways to improve your software system's ability to cope with the future, well, rinse and repeat. Thank you very much.
Hey, what's up? My name is Anatoly Makarevich. I came from sunny Belarus, basically to tell you about why I didn't sleep tonight. So in the next few minutes, I'll talk about something really static, about static analysis. So I came across static analysis when I discovered, like when I asked myself how climate actually works. And I figured out that there's a bunch of open source gems like Flock and Fly, like in the backend of the climate. And so here I'm talking about how they basically works. So to do a static analysis, you actually need to grab a bunch of your Ruby code and then to write another program which actually will analyze it. So you need to somehow represent a bunch of Ruby code, which is actual plain text, to some structure that can you iterate on. So it's actually an array. So this array is called as expressions, and like they are like 50-year-old, as Paul mentioned. And everything you need to know about S expressions is actually two things. The first of them is like the first element of the S expression is like the name of its name. It stands for a class, method, anything. And all the other arguments, or all the other elements in the S expressions, actually the arguments of it. So that's it. And actually, Ruby is aware of S expressions. So out of the box, Ruby has like Reaper class, which allows you, using 2 lines of code, represent any like piece of Ruby code in the format of S expression. It is actually an asset array. So that's it, 2 lines of code, and you have everything to write your own static analysis, gems, whatever. And yesterday, I was so impressed by Sandy Matt's talk, and I think like if can I do the actually implement a static analysis gem for checking these simple rules. And actually I did. After all the thanks. Actually, I did it like after 4 beers and volleyball, so don't blame me if it's somehow like messed up, but you can blame me right now. The internet is down, so you can install it. What it does right now, it just shows you the percentage of like classes, method, and method calls, which are like based to the standard rules. So that's it. Yesterday I turned 25. I think it's the best birthday ever. Thank you very much.
Okay. DevOps in the real world. Oh, I gotta stick close. I have this, but that will make me just move. Okay. Hi, my name is Vasilis Rizopoulos. I work for Zülke. That's an engineering firm in Switzerland and Germany mostly. And I'm one of the founders and organizers of Thessaloniki.rb, which is a small Ruby users group. Mainly, what I do is I help build small things and big things. This is where the real world comes in. When I say real world, I actually mean the real physical world. I've helped teams build things as small as that, or as big as that. Software for things as big as that, not the actual 60-ton beast. But they are complex things. I mean, even the smallest of those things are really complex. I mean, really, really complex. That last picture is the big mess of wires. Look it up on Google. It's one amazing exercise in masochism. And that's where DevOps comes in. So I'm going to take it very quickly out of the way. Keep using that word. I don't think we actually know what it means exactly, apart from, in my mind, being the actual bringing together of all disciplines, the development, the skills of both developers and ops people in one team together so that they can work about it. So I'm going to leave DevOps aside, although I put it on the title, and do the distinction of 2 things where DevOps methods actually work in our daily life. So let's talk about project infrastructure. Project infrastructure is, well, all these things. Application lifecycle management, fancy words for backtracking and requirements management or whatever. Version control, your build systems, your test systems, everything that runs in order to facilitate one thing. Everything that facilitates communication between your team, your stakeholders, all of that. Those are servers that actually need to run, and you need somebody to, take care of them so that the team can work and communicate. So what are the weapons of choice? Chef, virtual machines if you want, and a good ops engineer. I mean, having chef recipes doesn't mean that you don't need somebody who actually knows how to set up these things and make them run reliably. And then there's the other side of the pond. Then it's development infrastructure. This is about 1/3 of my daily life. My environment has 3 C compilers, 2 of them cross-compiling, Java, C#, Ruby, 4 readers, 4 IDEs, 6 editors, and, well, Edge managed to get out, but I'm still on Windows. Ouch. Yeah. So how do you keep that when one side of the room goes, it doesn't work, and the other one goes, works for me. So yeah, how do you do that? How do you actually handle when everybody does whatever they want, put the settings whatever they want, and then, so what's the word here? The word here is consistency. We need to keep our environments consistent across developers, across deployment, across development environments, staging, testing, all of that. How do we do that? Well, that's how I get to work with Ruby when I work in embedded teams. Rake, Vagrant, Chef. Okay, this is a lightning talk, so we won't get into details. Just keep this, communication and consistency, sanity preservation. Thank you.